Alright, today we are going to talk about standardizing and correlation matrices. In video 3.11 we talked about diagonal matrices, and these diagonal matrices are actually helpful in converting covariance matrices into correlation matrices. A Pearson correlation coefficient is a standardized covariance by definition. So first, we calculate covariance, then standardize it after the fact by dividing it by its two standard deviations, one for x and one for y. So the Pearson coefficient, correlation coefficient, marked by R, is the covariance divided by the standard deviation of x and the standard deviation of y. For the data matrix we got in video 3.2, we had some deviation scores that looked like this. 5, 6, 2, 0, negative 2, negative 2, negative 2, negative 3, negative 3, and negative 1. And the covariance was found to be 10.75, and the two variances were found to be 11.5 and 12.5. And so we got a covariance matrix C that looked like this. So as we know from these variances, the standard deviation is just the square root. So we get standard deviations of 3.39 and 3.54. So the correlation coefficient between x and y, let's write this out again. It's the covariance of x, y, divided by the standard deviation of x, standard deviation of y. So we know the covariance is 10.75, standard deviation 3.39 times 3.54. We can reduce that. We'll get about 12 here, and it equals 0.9. Now, using matrix algebra, we need a standardizing matrix. And this standardizing matrix is a diagonal matrix of reciprocals of the standard deviations, and we'll call that matrix E, and we'll get to that in just a second. So the steps to do that, we have the first step is to diagonalize the covariance matrix C. So we're going to denote that DIAG for diagonalization of C. Just going to copy down our covariance matrix here again. And if you recall, just to diagonalize that, you keep the diagonals and put zeros on the off diagonals, so it looks like this. So only the variances are left. The second step is to get the square root. Now for a diagonal matrix, simply take the square root of each element. So we're going to do square root of the diagonal of the covariance matrix. And what we get is 3.39 and 3.54, which I showed up here. The third step you get the inverse of the matrix. For a diagonal matrix, take the inverse of each element. So what we're going to do, we're going to call this E like I said before, and it's the inverse of the square root of the diagonal of the covariance matrix. I know that looks confusing, but since I showed you step by step here, it's pretty easy. Just take the inverse of what we just did, and what we get is 0.29, about 0.28. Now, once again, what I did is right here, I did 1 over 3.39, and right here I did 1 over 3.54. That's the inverse. Now this is actually called the standardizing matrix. Now the covariance matrix pre and post multiplied by the standardizing matrix E will give us the correlation matrix, and we will call that R. Now remember from the previous video, when you pre-multiply, it standardizes the covariance matrix by its rows, and when you post-multiply, it standardizes the covariance matrix by its columns. That's when pre or post-multiply by this standardizing matrix. And just to remind you, I'll write that here. Okay, so let's get the correlation matrix. Like I said, you pre-multiply and post-multiply the covariance matrix by the standardizing matrix. So what we'll get is matrix E times matrix C times matrix E again. And simplifying that, let's get E times C first here. We get 3.39 and 3.17 when you multiply these two together, and 3.04, about 3.54. And then post multiply that by E. And what this gives us is 1, 0.9, 0.9, and 1. And as you notice on the off diagonals here, we've got 0.9, which is the same as we got up there. Remember, this was the Pearson correlation coefficient, and this is the correlation matrix. So we should have 1s on the diagonals and then our correlation coefficient on the off diagonals. So for two variables, we get one correlation coefficient. In this case, 0.9. Now let's go over to Excel, and I will show you how to do this. Okay, let's just focus on the left section over here for right now. I've highlighted our variances here on the diagonals. So what we're going to do, we've got our covariance matrix, and now we're going to put here our diagonals, which is 11.5 and 12.5, and zeros here. Okay, so what we're going to do is take the square root. You can do this two ways. What I will do here is use the square root function. So you hit equals SQRT, And then let's take this matrix, Control Shift Enter, and we get the square roots here. Now to do the inverse, which is the next step, we've got zeros on the off diagonals, and you just take, for this one, 1 divided by that one. Control Shift Enter, you can do if you want. Goes 1 divided by this number. Just hit Enter there. You don't have to actually hit Control Shift Enter. Okay, so that's our third step. Now the first process in getting our correlation matrix here, so we're going to multiply the standardizing matrix, which is E, times the covariance matrix. So that's just a simple matrix multiplication. Sorry. And then E, comma, C, close your parenthesis, Control Shift Enter. And then we're going to take this and just multiply it by E again to get our result. So EC, comma, E. Alright, and as you notice, in my notes I just rounded to 2 decimal points. This goes a little further, so it's a little different, but essentially it's the same. We get 0.09. And actually I can extend the column width to show that these are actually equal. But what I want to do is make them the same excuse me, I said 0.09 before, it's just 0.9. Okay? Now once again, C is your correlation matrix. Diagonal is just the diagonalization of C. We took the square root, got the inverse of that matrix, and in order to get our correlation matrix, we did standardized matrix. You pre-multiply the correlation matrix by the standardizing matrix, and then post-multiply that times our standardizing matrix. That's a mouthful. Now, that's an example with just 2 variables. We can do an example with 3 variables, and I've already prepared that over here to the right. So let's take a closer look here. Okay, so what I did, I just added another variable, and I said let's just have the variance be 16. And I'll extend these so I can show you it's actually 10.75. Now the diagonals is very easy, just put that in here. Okay, and let's get the square root. Take the square root of this matrix here. Okay, now the inverse, I'm just going to do 1 divided by this first value here. Excuse me, I forgot to hit equals. Second one, and the third one. And once again here, the inverse is just 1 over these numbers, so 1 over 4 is 1/4, 0.25. You can clearly see that there. So let's get pre-multiply the standardizing matrix times the correlation matrix. Okay. And then post-multiply by the standardizing matrix. Alright, there you go. And here in the Carolina blue colors, we actually have 3 correlation coefficients. So for 3 variables, 1, 2, 3, we'll have 3 correlation coefficients. And actually, if you increase to 4 variables, you'll come out with 6 correlation coefficients, and it just gets larger as the variables go up. So that's a demonstration of if you have more variables and how you can get a correlation matrix. And once again, that is a summary of standardizing correlation matrices. Let's try to compare what we have here in Excel with what we did by hand. Alright, as you can see here, we did get 0.9 as our answer, and you can compare that the values are very close. Right here is our square root matrix that we got, 3.39, 3.54. It's the same, inverse is the same, and our answer is the same, and that's how you do standardizing and correlation matrices.